This is the first in a series of tutorials designed to help UNL students use the Quick Circuit 5000 PCB mill, which is currently located in PKI 340. The first thing you'll need to do is to generate your Gerber files from your PCB design software. What you will need is, for a single-sided board, you will need the board outline file, the solder side copper file, and the drill file. And if you have a double-sided board, you will also have a component side copper file. You will take those files over to the computer with a flash drive, and you will place them in the ISOPRO projects folder. I've already done so for this tutorial in this folder called PCB tutorial files. Then you will open up the ISOPRO PCB mill software program. This is the proprietary T-Tech program that runs the PCB mill and the program that you will be working with your copper layers in. As you open this up, you will notice that it takes you to the representation of a large black square with a dot. This is a representation of the workable area of the copper sheet that you will be given. You will be given a 9-inch by 12-inch single or double-sided copper sheet, and of that you will be able to use 8 inches in this direction, 4 inches from either side of the center pin. This is because the mill has a pressure foot that rides along the copper along that extra half an inch on each side for a double-sided board. Then you will have 3/8 of an inch at the bottom here. We will work with this area later. This dot indicates where the center homing pin that holds the board in place and gives it a center line, so that when you do a double-sided board, when you flip the board over, it is an exact mirror image that the mill will duplicate on the other side. The other pin, there will be another pin, and it will be located up in this area. This line is at 10.7 inches, which is the maximum distance that the x-axis on the mill will move to. There's a limit switch that prevents it from moving farther than that. And you'll notice down here in this corner, this tells you what position on the board in the coordinate system that you're on. If you place your cursor on the dot, that will be around 0, 0, and then everything will proceed from there. So, importing your files, you will go to File and then Import, and you will want to use this Auto Detect Files. There are options for importing Gerber and drill files, but those will ask you for the exact settings of your file. If you know those, you can use those options. Here we will select Auto Detect Files, and we will import our files in the following order. We will first import, for both single and double-sided boards, the board outline file. In Eagle, which I use, this is generated in the top silkscreen file or the .plc file. So I will double-click on that, and here I know that Eagle generates in 2, 4 absolute. This is actually leading, 0 suppression, and units of inches. Notice these are integer digits, decimal digits, the coordinate mode absolute or relative, the 0 suppression, either leading zeros or trailing zeros, and what units, either inches or millimeters. So I know that this first option is the right one. I will select that, and there is my top silkscreen file. You can see the board outline around it, and we will extract that later. The next thing you want to do, if you have a double-sided board, is you will want to import the component side copper. So we will go to Auto Detect. That file in Eagle is a .cmp file. We will import that. If you have a single-sided board, you won't have this one. You can select Open or double-click on it. I know that is that file. The next thing we will do is import the solder side copper. If you have a single-sided board, this is your only copper layer. If you have a double-sided board, this is the solder side. In Eagle, that is a .sol file. I will double-click to select that, and I will choose the appropriate measurements. And the last thing we will do is Auto Detect file. We will import the drill file, which in Eagle is a .drd file. This is an NC or Epsilon drill file. I select that, and I notice here that all of the system's best guesses are in millimeters except one, which is in inches. That's the one I want. This is the rough size of your board, the number of integer, decimal digits, and so forth. I want this one because you'll notice these file extents are nowhere similar to the file extents that are on my actual board. This is the closest match, so I will select this one, and you can see the drill file imports there. Then I will save this file as in the same file that you imported, and you can call this, for this purposes of this tutorial, I will call this tutorial 1. This will save as a .iso file, and this is the file the software will use when we generate our milling pass and mill the board. I want to save that because every so often this program will auto-save your work, and we don't want it to access the flash drive. We want it to auto-save in case we forget to save. As usual, the more you save, the better off you will be. In the next tutorial, we will look at reviewing the layer table and how this will assist you in working with your layers.